Work. Standard 11th, Chapter 6, name is Work, Energy and Power. We are starting from work. Definition is when a force acts on an object, यानी जब force is applied on an object, then object actually will move in the direction of a force. If it is happening, then we will say yes, W, there is a work done by the force. Okay, by the force. Second sentence is second sentence work done by the force is equal, यानी W is equal to product of force and displacement. Product means multiplication. F into S will be equal to W, which is work done. So work done by the force, जो फोर्स लगाया गया ऑब्जेक्ट पर उसके द्वारा कितना वर्क हुआ वो इक्वल होगा मल्टीप्लिकेशन ऑफ अ फोर्स एंड डिस्प्लेसमेंट ऑफ द ऑब्जेक्ट इन द डायरेक्शन ऑफ अ फोर्स. सिंपल बात. फोर्स अगर फोर्स लगाए ऑब्जेक्ट पर और जिस डायरेक्शन में फोर्स लगाया गया अगर उस डायरेक्शन में ऑब्जेक्ट मूव किया या डिस्टेंस कवर किया तो वो हमारा वर्क डन हो जाएगा बाय द फोर्स, जो लगाया गया फोर्स. इन इक्वेशन इट इज़ रिटन लाइक दिस, W इज इक्वल टू F इंटू एस. अगर किसी एंगल पर फोर्स लगाया जाता है तो हमारे पास कोस थीटा होता है, वाई नॉट साइन थीटा. रीजन इज वर्क इज a scalar quantity. For a scalar quantity we use cos theta, for vector quantity we use sin theta. Okay, if under a constant force F, the object displaced through a distance S, then work done by the force. This is our equation. F is equal to F into S. If there is a theta, so our equation will be F equal to Fs cos theta. If angle is zero, so our equation will be what? W is equal to F into S, where theta is 0. When A is the smaller angle between F and S. Work is a scalar quantity. Yeah, its SI unit is joule. Whenever energy word is coming, work, energy, so remember SI unit of work will be joule, SI unit of kinetic energy, potential energy will be always joule, and CGS, centigram second, is erg, ERG. 1 joule 10⁻⁷ अर्ग के बराबर होता है. इसका डायमेंशनल फार्मूला हो जाएगा ML/T-2. दिस इज द डायमेंशनल फार्मूला ऑफ वर्क. वर्क डन बाय ए फोर्स इज ऑलवेज 0 if angle is a 90 degree. Okay, body is not displaced, actually S is 0. if body displaced नहीं किया after applying force, then our work done will be 0. Bodies are displaced perpendicular to the direction of a force. If angle theta is 90 degree, then our work will be 0. Bodies are displaced perpendicular to the direction. अगर बॉडी डिस्प्लेस नहीं हुआ तो वर्क डन 0 हो जाएगा. अगर एंगल 90 डिग्री है तो वर्क डन 0 हो जाएगा. वर्क डन बाय ए फोर्स इज अ पॉजिटिव if angle between F and S is an acute angle. If there is an angle which is less than 90 degree, our work done will be positive. If you put cos 0, your answer will be positive plus 1. If you put 180, your answer will be negative. That's why Work done will be negative if angle is more than 90 degree. Work done by a force is a negative if angle between F and S is a obtuse angle. अगर एंगल ऑब्ट्यूज है यानी 90 डिग्री से बड़ा है तो वर्क डन विल बी नेगेटिव. वर्क डन बाय ए कांस्टेंट फोर्स. अगर फोर्स कांस्टेंट है यानी हर एक जगह पर फोर्स सेम है, वैरी नहीं कर रहा. वर्क डन बाय ए कांस्टेंट फोर्स डिपेंड्स ओनली ऑन द इनिशियल एंड फाइनल पोजीशंस and not on the actual path followed between initial and final position. For constant force, only we take initial and final position. That's it. You don't need to care about actual path. Okay. When it comes to constant force, work done in different condition. First, we saw force. If force is a constant, then we will take only final location and an initial location. If a force is a variable, work done by a variable force is given by, तब calculus is used. W will be equal to integration of F into ds, where ds is a small distance or a small displacement. In that case, our simple equation will be equal to W is equal to integration of F into ds. It is equal to the area under the force displacement graph along with the proper sign. थ्रू ग्राफ देखा जाए तो हम टोटल ऐड करेंगे ग्राफ को इस ग्राफ में. इस ग्राफ से हमें रेक्टेंगल, ट्रायंगल और ट्रापेजम मिल सकता है. उसे उसका एरिया निकाल कर जो एरिया निकलेगा, अगर फॉर एग्जांपल हमारे पास ट्रापेजियम है, उसका एरिया निकाला जाए फर्स्ट ऑफ ऑल, देन ट्रायंगल का एरिया, देन रेक्टेंगल का एरिया, फिर उसके बाद ऐड अप करके हमारा वर्क डन आ जाएगा. ये ग्राफ के थ्रू, इस तरह ग्राफ के थ्रू निकाला जाएगा. सेकेंड, वर्क डन इन डिस्प्लेसिंग एनी बॉडी. Work done in displacing any body under the action of a number of forces is equal to the work done by the resultant force. In equilibrium means if a body is in a rest or moving with a constant velocity is known as equilibrium. The resultant force is a zero. Therefore, resultant work done will be zero. चूँकि बॉडी रेस्ट में है और देर इज नो डिस्प्लेसमेंट, तो वर्क डन विल बी ज़ीरो. वर्क डन और रिजल्टेंट फोर्स विल बी ज़ीरो. We will see it later. If work done by a force during a rough trip of a system is zero, then the force is a conservative. What is a conservative? What is a non-conservative? Otherwise, it is called a non-conservative force. Work done by a force during a rough trip of a system is zero. अगर body after traveling it comes to the initial position, then work done will be zero. Now let's try to understand conservative and non-conservative force. Conservative means that force will not care about actual path. So that type of a force is known as a conservative force, like gravitational force, electrostatic force, magnetic force, etc. All these are conservative force. When we are taking gravitational force, here we will not care about actual path. Okay, only we will see vertical or a straight line. All these central forces are conservative forces. Even gravitational force is also known as the central force. Non-conservative force means we take we consider actual path. Okay, all the length or all the displacement we will take. So that kind of, for example, friction force, viscous force, all these are non-conservative. For friction force, we need to consider actual path. Fifth, work done by the force of gravity on a particle of mass m is given by the W is equal to mgh. Yani this is nothing but gravity, force of gravity. There is an object at a certain height. In that case, what will be work done? So just formula is mgh. This formula we will use. W is equal to mgh, where m is a mass, j is a gravitational force, and h is a height. If a body is at certain height from the surface of the earth, then our work done will be equal to mch, where gravity is a conservative force, where z is the acceleration due to gravity, and h is a height through particle one displaced. Work done in compression, when it comes to compression or stretching a spring, then formula will be equal to W is equal to half kx square. जब स्प्रिंग को स्ट्रेच या कंप्रेस किया जाएगा, तब फॉर्मूला वर्क डन विल बी इक्वल टू हाफ के एक्स स्क्वायर, where k is a spring constant and x is a displacement from mean position. K is a spring constant and x is a displacement from the mean position. Seventh, when on end of a spring is just attached, when on end of a spring is attached to a fixed vertical support and a block attached to the free end moves on a horizontal. Table from x is equal to x1 to x is equal to x2. Then our formula will be nothing but to half k x square x2 minus x square x1. Work done by the couple for an angular displacement. Theta is given by the W is equal to I into theta, where I is the torque of the couple. Couple for an angular displacement means power. The definition of it will be the time rate of work done by a body is equal to its power. Time rate. Then our equation will be P is equal to W upon T, dW upon dt. Power is equal to rate of doing work, which is equal to work done upon time taken. If under a constant force, if a body is displaced through a distance as in time t, then power will be equal to W upon T, and W is equal to F into S upon T. But S upon T is a V, uniform velocity with which body is displaced. So just F into B. This will be equation for power. P is equal to F into B, which is equal to F into B cos theta, where theta is the smaller angle between F and B. Power is a scalar quantity. Remember, it is also a scalar quantity. It will not provide a direction. Its SI unit is a watt, and its dimensional formula is ml square t raised to power minus 3. Its other units are kilowatt. There is a one more unit which is kilowatt and horsepower. 1 kilowatt is equal to 1000 watt and 1 horsepower is equal to 746 watt. Now let's see energy. Energy of a body is its capacity of doing work. एक बॉडी के पास कितनी कैपेसिटी है एक वर्क करने के लिए, दैट इज नोन एज एनर्जी. एक बॉडी के पास, बॉडी कैन बी एनीथिंग, नॉन लिविंग थिंग और लिविंग थिंग बोथ. So that the non-living thing body has how much capacity to do work will be known as energy. This energy is a scalar quantity. It does not provide direction. Its SI unit is a joule and CJ unit is a erg. Its dimensional formula will be equal to ml raised to power 3 t raised to power minus 3. There are several types of energy such as mechanical energy, kinetic energy and potential energy, which we will see. Chemical energy, light energy, heat energy, sound energy, nuclear energy, electric energy, etc. All these are types of energy. So our unit will be same. Diamond unit will be same when it comes to energy, no matter what kind of energy. If energy is coming, our unit will be same. Mechanical energy, the sum of a kinetic and potential energy at any point remains constant throughout the motion. जब काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी को सम कर एट एनी पॉइंट अगर रिमेन रहे सेम रहेगा थ्रू आउट द मोशन, दैट विल बी नोन एज अ मैकेनिकल एनर्जी. बट इट इज अ कन्वर्ज्ड, इट डज नॉट डिपेंड अपॉन टाइम. दिस इज नोन एज लॉ ऑफ कंजर्वेशन ऑफ मैकेनिकल एनर्जी. मैकेनिकल एनर्जी इज ऑफ टू टाइप्स. First we have kinetic energy and second we have potential energy. First of all, let's see kinetic energy. The energy possessed by any object by virtue of its motion is called its kinetic energy. एक बॉडी के पास एनर्जी होती है जो मोशन को बनाए रखती है, उस एनर्जी को काइनेटिक एनर्जी कहा जाता है. काइनेटिक एनर्जी तब ही बॉडी के पास होगी जब वो मूव करे. जब बॉडी मूव करती है तो उसके पास काइनेटिक एनर्जी होता है. Kinetic energy of an object is given by K is equal to half mv square. This is the formula of a kinetic energy, half mv square. If we see relation of momentum and between momentum and kinetic energy, then we will get a equation which will be equal to K is equal to p square upon 2m. Just you put 1 upon 2 mb, just multiple 1 by 2 mv square by m, then you will get p square upon 2m. To find the relation between momentum and kinetic energy, we will have this equation K is equal to p square upon 2m. Where m is the mass of the object, u is the velocity of the object, and p is the mv momentum of the object. We know all these things. Now it's time to see about potential energy, the energy possessed. Remember, if a object is at a certain height, then object will gain potential energy. When that object will be released, then that object will convert potential energy into kinetic energy during the motion. The energy possessed by any object by virtue of its position or configuration is called its potential energy. There are three important types of potential energy. First, gravitational potential energy. We are crystal clear about potential energy. It says that if a body is at a certain height, then that body will gain potential energy to move. Okay, to move. Now, first we have gravitational potential energy. This is taught in the chapter of gravitational. Right now, just we are taking a little bit explanation about it. Gravitational potential energy. If a body of mass m is raised through a height h against the gravity, then its gravitational potential energy will be equal to mgh, which is a familiar equation. If a body is at a certain height and this body is working against gravity, then our formula will be equal to potential energy, gravitational potential energy will be equal to mgh. Okay. Elastic potential energy. If a spring of a spring constant k is stretched through a distance, when a spring will be stretched uh, at a by some distance, then our elastic potential energy of the spring, जब हम लोग स्प्रिंग को खींचते हैं स्ट्रेच करते हैं, तो जब स्प्रिंग को स्ट्रेच किया जाएगा तो at some distance that spring will gain its initial its potential energy, which will be 1 1 into 1 by 2 kx square. This is the elastic potential energy, 1 by 2 kx square, where k is the spring constant, x is the distance. The variation of a potential energy with a distance is shown in figure. Potential energy is defined only for conservative force. It is valid when force is a conservative, not non-conservative. Okay, it does not exist for non-conservative force. This is a valid if potential energy is, if there is a force which is a conservative, then this is valid for potential energy. If force is a non-conservative, then this will be invalid for potential energy. Potential energy depends upon frame of reference. Frame of reference will matter for potential energy. Third, we have elastic potential energy. Elastic, not elastic, but electric potential energy. The the electric potential energy of two point charges Q1 and Q2. When it comes to electric, we take a column, two columns, two charges Q1 and Q2, separated by a distance. Both are kept at some distance. R in vacuum is given by U which is the electric potential energy, which is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R, where Q1 and Q2 is charges and R is a distance between them. Here 1 by 4 pi epsilon naught, value of it is 9.0 into 10 raised to power 10 Newton meter square per CO square. Constant. This is a constant. 1 by 4 pi epsilon naught, it is a constant. Now we came to the work energy theorem. This is nothing but total work done by all the forces that are being applied on an object. Work done by a force in displacing a body is equal to change in its kinetic energy. So over here we have equation which is W is equal to integration from V1 to V2 F into ds. V1 is initial to final. Initial to final velocity, what is the work done? So formula is the same, just we are using calculation. And remember, this work energy theorem will be equal to half mv square, where v is the final, minus a half mv square, where v is the initial. Means final kinetic energy minus initial kinetic energy is equal to work done by all the forces, and we can write it as a final kinetic energy minus initial kinetic energy is equal to change in kinetic energy. When we write initial final displacement minus initial displacement, it means it is equal to change in displacement. Final velocity minus initial velocity is equal to, we write it as change in velocity, where ki is initial kinetic energy. From I, we understand that this is nothing but initial. K is a kinetic energy. Kf means final kinetic energy. Regarding the work energy theorem, it is worth noting that if W net work done is a positive, then change in kinetic energy will be positive. Over here, if work done is a positive, so final kinetic energy will be more, but initial kinetic energy will be less. Kinetic energy will increase and vice versa, opposite. If net work done is a positive, kinetic energy will increase. This theorem can be applied to non-inertial frames also. In a non-inertial frame, it can be written as work done by all the forces, including pseudo forces, will be equal to change in kinetic energy in non-inertial frame. When it comes to non-inertial frame, we see that there are two bodies and both are accelerating. This is known as the non-inertial frame, where Newton's laws of motion of Newton's is invalid in front of a non-inertial frame. Okay, so here work done by the all forces can be found even we have non-inertial frame. That is a valid. So change in kinetic energy is equal to work done by all the forces. Mass energy equivalence. Equivalence means equal. This theorem says, it is not theorem. I don't know. I don't have. I can't say that this is theorem, but it is. It says, it explains that mass can be converted into energy and energy can be converted into mass. So both are equal. Mass is equal to energy. This is the meaning of a mass energy equivalence. According to Einstein, this is person who said that the mass can be transformed into energy and vice versa, just opposite. Both will be opposite. Yeah, this is true. We see that mass has a potential energy, mass has a kinetic energy. If a mass is moving, it means mass has a kinetic energy. So this was true according to Einstein. We saw, yes, if a body is moving and body has a, if a body is moving due to kinetic energy, just body was converted by the help of kinetic energy. When change in mass disappears, then produced energy will be, when mass disappears, then produced energy will be equal to, E will be equal to delta mc square, where m is a mass and c is the speed of light. C is the speed of light in vacuum. Principle of conservation of energy. Conservation of energy. The sum of all kinds of energy in an isolated system remains constant at all the time. Just you need to add all the energy, all kinds of energy. Then you see uh, all the energies are constant at all the time. So we see, yes, this is a principle of a conservation of energy. Principle of conservation of mechanical energy. For conservative force, for example, gravitational force, electrostatic force, all these are conservative forces. For conservative forces, the sum of kinetic and potential energies of any object remains constant. Of any object remains constant throughout the motion. When we take conservative force, then we will see that the sum of a kinetic energy and potential energy of any object will remain constant throughout the motion. throughout the motion will be constant. According to the quantum physics, mass and energy are not conserved separately but are conserved as a single entity called mass energy. Collisions, collision between two or more particles is the interaction for a short interval of time. Means there are two bodies and both are coming near, and there happened a collision between them. So for a short interval of time, we get collision, and we see that after collision and before collision, there will be change in velocity. Before collision, will velocity initial velocity of both was something else, but after collision, velocity is something else. This happens. This happens in which they apply relatively strong forces on each other. In a collision, physical contact of two bodies is not necessary. Here are two types of a collision. First, we have elastic collision. The collision in which both momentum and kinetic energy of the system remains conserved are called elastic collision. It means after collision, we will see that kinetic energy and momentum are conserved, not lost. Okay, not lost. Means after collision they will move. They will cover some distance. This is known as elastic collision. In an elastic collision, all the involved forces are conservative force. Total energy remains conserved. In elastic collision, here we will see what lost energy. The collision in which only the momentum remains conserved, but kinetic energy does not remain conserved are called inelastic collision. Here kinetic energy will be lost. But when it comes to momentum, momentum remains conserved. In an elastic collision, some or all the involved forces are non-conservative force. Yes, over here जो भी forces होगा इन इलास्टिक collision में वो सभी forces non conservative forces होंगे. Total energy of the system remains conserved if after collision two bodies stick to each other. If after collision of the bodies, if both are stick to each other, it means they didn't cover distance after collision. Then the collision is said to be perfectly elastic. It means after collision, if bodies that didn't cover distance, then this type of collision will be known as a perfectly elastic inelastic collision. Coefficient of restoration or resilience. Let's see what is it. The ratio of a relative velocity of a separation means before momentum and after momentum. After before collision, what was the momentum of the body, and after collision, what is the momentum of the body. So the ratio of these two momentums will be our coefficient of restitution. So the ratio of relative velocity of separation after collision to the velocity of approach before collision is called coefficient of restitution relation. It is represented by E. E will be equal to, it is represented, means coefficient of restitution is represented by E, and it depends upon the material of the colliding bodies. What type of bodies are? So for a perfectly elastic collision, E is equal to E is equal to 1. If there is a perfectly plastic elastic collision, so E will be equal to 0. Means there will be momentum will not be equal to 0. For a perfect inelastic collision, here body will stick to each other. After collision, they will not cover distance. Then our E will be equal to 0. For all other collisions, 0 elastic will be what, not less than 0 but greater than 0. One dimensional or head on collision means in one dimension. After collision, body will move only in one dimension, either in horizontal or vertical. If bodies are coming horizontally, then after collision they will move horizontally. This is known as a one dimension. If the initial and final velocity of the colliding bodies lie along the same line, then the collision is called a one dimensional or head-on collision. Simple, just understand. In one dimension, there is collision will happen, and after collision, they will move in the same line. In elastic one-dimensional collision, applying Newton's experimental law, we have first momentum of the body is m1 into v1, and second momentum of the body of the second body is m2 into b2. So over here, after collision, same, but momentum will be different after collision. So according to, after applying Newton's experimental law, we will get this v2 minus v1, which will be equal to u2 minus u1, u2 minus u1. Velocity after collision, which is v1 is equal to m1 minus m2 into u1. This is equation. Here, two-dimensional or oblique collision means two-dimension is board if bodies are coming in same line, but after collision they can go in two axes, x-axis or y-axis. This is a realistic example. We see that there are two bodies, both there are two bodies, and after collision they go in different axes, in x-axis, y-axis.